In this part 2 video, we will explain that how we have implemented the RL policy. In the part 1 section, we explained the always on policy, where I described how the model is functioning. In this video, I will explain the implementation of RL policy. In the always on policy, there was not the standby state wasn't used, but in this RL policy, we will use standby state as well. Now, to implement reinforcement learning in Anylogic, there is a special feature in Anylogic known as RL experiment, which has three sections. First is observation, second is action, the third is configuration. In the observation, we defined what parameter should the agent be observing, what act, and for the action section is what the agent should take action. And in the configuration, we define the default values of the simulation, initial values of the simulation. Now, the point is that uh, we wanted to train our RL agent in Python, and we wanted to use Python based libraries. And but the problem was Anylogic native language is Java. But Anylogic offers some open source libraries to help train the RL agent in Python as well. And one of those is Alpine library. Alpine library is used to train the RL agent in Python for the Anylogic program. And if we want to communicate, if we want to write code and use any Python based file, there is another library called Pipeline, which can help to read the Python code and use Python libraries in Anylogic. Now, how it works, let me just explain it. First, once we have defined it, the RL agent, and we will export the file. We will export the file to the following directory, and the exported file will look like this is the folder which is exported. It contains a model.jar file which we will use in order to train the machine state model, to implement reinforcement learning in the machine state model. Uh, to train the RL agent, I have developed a Python based file which is using PPO to train the RL agent. I'm using PPO from the stable baseline 3, and I am importing the jar file into my Python file to train the RL agent. And once it is trained, a file called as multi-stage control PPO will be generated. As you can see, this is the file which is generated after the training. Once it is trained, now the problem is how this file is going to interact with the Anylogic in the runtime. For that, we need to create a channel, a Python based channel. So because this multi-stage control PPO is in Python, and we have to create a communication channel between this file and Anylogic during the runtime. For that, we have created another Python file which is coded in Python, and the purpose of it is to create a channel between trained file and Anylogic. This one. This is the file which is created. Now let's run the simulation and it's taking some time. Yeah, initially you can see that all the machines are in a standby state. Now, after every 7 seconds, which I have defined, but we can also change the time, it depends on us. An RL agent will give an output, give an action, make a decision and take an action. It's 2 3 seconds. Now once there will be yeah. Now the action was that target machine 1 in the stage 1 2 machine should be operating 5 machines, and it has make a decision, and according to that decision the machine will change their states. As you can see, for the target machine, for the stage 1 the decision was uh, to make 2 machines operating. So from the standby state it has gone into the startup state, and from it for the second machine that it has also changed the state to idle. In the similar way, it also happened with the stage 2, stage 3, and stage 4. In this way, RL agent is implemented, and we have the graph which will show that how much energy is consumed. We can change the interval as well, that at what time should the RL agent take action. So it depends on us, and we can also change the strategy. Instead of using time to take an action, we can change, we can come up with a different approach, like take an action when a change occurs in the buffer or something like that. And this way we can improve the results as well. So this is the small demonstration for the RL policy.